Theorem, special right triangles, converting angle measures, that's from degree to radians and vice versa. We have coterminal angles and we have reference angles. So Pythagorean theorem was discussed during the first trimester and it continued during the second trimester, and up until now, it's the official time to really discuss it properly, because the last times those were just applications, but we will not dwell on this one as you are already used to the topic. First is this: how will we solve Pythagorean theorem, everyone? So remember that we can only use Pythagorean theorem. The keyword there is Pythagoras. It's the name who discovered Pythagorean theorem. We will use this c squared equals a squared plus b squared. Tech check. Can you see the cursor? You can leave a reaction, like reaction, if you can see it. Can you see the cursor, an arrow that is moving? Easy. Okay, thank you, Mary. Okay, there, c squared equals a squared plus b squared. Remember, guys, that c is the longest side. And to be safe, that is the side opposite our right angle. Here in PQR, the longest side is 13 cm. That's the side opposite this right angle, which is denoted as a square. That means it's right. So in solving for the missing side, we simply substitute it to the theorem, to the formula, c squared equals a squared plus b squared. And always go first with the c. Since it's given there, that's 13, we substitute it here, that's 13. And then a and b, these are the legs. These are the other two sides of your triangles. And these two letters can be interchanged. This 12 given can be a, it can also be b. Here, I am using it as a. And that's 12 squared. Remember in the formula that our sides, A, B, and C are squared. That's why it's squared here. And then we simplify. We combine like terms. We will transpose, Filipino term, 12 squared to the left. So that will make, that will be 13 squared minus 12 squared. So we have here, and then the b squared. And then we simplify further. 13 squared is 169. 12 squared is 144, and we subtract the 2, that's 25. Common mistake, you will end here, 25 only. Take note that the sides are a, b, and c, not a squared, not b squared, not c squared. So we need to get the square root of 25, and that will give us 5. So the answer for this one, the third side of the triangle PQR is 5. Okay, that's how you solve missing sides in a right triangle. Any questions with the Pythagorean? Since that is just it. I'll be calling some students to just answer or respond if you got it right so that I can proceed to the next one. Let's have Christine. Questions, Christine?
None so far, miss.
Okay, thank you. I'll proceed now to kanya siya, all the activities that were given. That's what I will discuss basically. I hope, yeah, most of you already did it, so very good. Continue to do that in our future activities. So activity 1 is about the special right triangles. We have 2. These are special because, of course, there are people who are special. No? It also applies to things. In triangles, we have 30, 60, 90, and 45, 45, 90. If you're given with a triangle, which a right triangle, and then the other one is 60, of course, the third angle will be 30. And then if there's a right triangle and then another 45-degree angle, of course, the third angle will be 45 degrees. That is true because the sum of the measures of our triangle, interior angles of a triangle is 180 degrees. So it's not necessary that you are really given with all the angles now, 30, 60, 90. It may not be very obvious because sometimes only two angles are given. But if you know that, later, if you'll compute for the third angle, you'll know nga it's a special right triangle. So, what makes it special? Let's go directly to examples. Let's start first with 30, 60, 90. This is the easiest question that will be asked from you for 30, 60, 90. You are given with this triangle. Diba? You see, we have 90 degrees angle in number 1 and 60 degrees angle. And we need to find for x and y. And these x and y are two sides of a right triangle. Diba, in the previous topic, Pythagorean, we need to have two sides. What about only one side is given? Take note, guys, that we have the 60 degrees and we have a 90 degrees. So it's a special right triangle. And 30, 60, 90 has properties that we can remember and apply in order to find for the missing side. What are those properties? First, you need to look for the shortest side. How will you know that it's the shortest side? It is the side opposite to our smallest angle. The smallest angle of a 30, 60, 90 is the 30 degrees. So here, in the upper part is the 30-degree angle and opposite to it is 8. So we have located it already. Next thing is we need to know the longer side. Longer side is the other side, not the hypotenuse. Kaya you know naman, hypotenuse is the opposite side of our right angle, which is denoted with a square or represented with a square. So x here is our longer side. And how do we get the properties of, how do we get the value of x? In a 30, 60, 90, after you locate the shorter side, the longer side will be just times square root of 3. So copy the given value and then add square root of, multiply it by square root of 3. That's why we have 8 square root of 3 here. And then for the y, the hypotenuse, just double the shortest side. Double the 8, that's 16. So kanara siya. And then we have another one here for number 3. Diba 14 is the opposite side of the shortest, smallest angle 30. So the longer side is y. You just simply multiply it with square root of 3. So that's why we have 14 square root of 3. And then the x, the hypotenuse, that is just twice our shortest side. So that's 14 times 2, 28. Okay, so you remember everyone, you remember that we need to find for the shortest side first. Let's stick to 30, 60, 90. The second level of difficulty that can be given to you for a 30, 60, 90 is, here. This word problem here. You are given with an equilateral triangle. Equilateral meaning 3 sides are equal, diba? And you need to find the altitude. That's the length, that's the height of our triangle. And if you divide the equilateral triangle, guys, it will give you a 30, 60, 90. So in order to find that, you need to just divide the side by 2 and then times square root of 3. Ano man? Why? The hypotenuse is given because it's the side of our triangle, equilateral triangle. And then going here, from this part of our triangle to the middle one, which is being cut by the height or the altitude, that is 10 divided by 2, the side divided by 2. Kaya the altitude divides our side equally. So 5 here. And in order to find for the height, diba, this is 60 man here. By each angle of equilateral triangle is 60 man. And then, kanisha, this is full 60. This one is being half. So this becomes 30 here. So that makes this cut side as the shortest side. So this becomes 5, or hypotenuse divided by 2. And then the altitude, kaning represented by x here, diba, the longer side is just square root of 3 times square root of 3 of our shortest side. That's why x here is 5 square root of 3. Okay, and then the hardest, okay, let's have those terms lang. The hardest problem that can be given to you about 30, 60, 90 is this question, is like question number 5. Kaning, the longer side is given and you need to find the shortest side and the hypotenuse. So with that, if that's the case, you need to solve first the shortest side. Okay, guys, it's easy man. From the shortest side to the longer side, you simply multiply it by 2. So you do the hard part first. And in remembering the properties, no, we need to remember, we need to base it from the shortest side so that we won't be confused. So in solving for x, diba, from x to kaning 12, we will multiply by square root of 3. But what if we go back here, the x? So we simply divide it by square root of 3. That's the reverse process of multiplication, division. 12 divided by square root of 3. Kana siya. But that is not simplified. Remember our first module in grade 9, rationalizing the denominator, that's simplifying radical expressions. So basically, just remember whatever the denominator is, that's square root of 3, you multiply it to the numerator and the denominator. That's how you simplify your answer. That's why we have here 12 over square root of 3 times square root of 3 over square root of 3. And that will give us, okay, we have a fraction and a fraction. Multiply the numerators, multiply the denominators. That's 12 square root of 3 over 3. And we can divide 12 and 3 here. That's outside the radical. No, that's 12 divided by 3, that's 4. So we have 4 square root of 3 as the simplest answer. So basically, that's 12 divided by square root of 3. So whatever the longer side, you divide it by square root of 3. You simplify. To remember, no, that's just 12 divided by 3, that's 4, and then add square root of 3. So the number that is being repeated in a 30, 60, 90 is the square root of 3. That's the the relationship between the shorter side and the longer side. And then after getting the x, you can get the y, but it's only twice. 4 square root of 3 times 2. That's 8 square root of 3. So that's for 30, 60, 90. Sige. And for 45, 45, 90, this is very easy to remember because our legs are equal. Okay, here in number 2, the legs. So it's not the hypotenuse. We have one leg 14 and x the other leg. Since they are equal, it's also 14. And then if in 30, 60, 90, we will multiply by 2. Kanisha, it's not 2, but square root of 2. Be careful ha, you multiply it by square root of 2 for 45, 45, 90. Okay, and let's have another one. Let's see if we can have another. Okay, here, number, wait, wala nila in. Second level of difficulty, kani number 8. It's a square, and do not fret if you're given with a square. If you will divide a square through its diagonal, it can give you a right triangle. Ani, where the legs are equal. Okay, the sides of a square are equal man. So in order to get this another side, it's also 18, and then kaning the diagonal of our square, it's times square root of 2. That's why we have 18 square root of 2 for number 8. And let's go to, wait lang ha, I'm calling the others who are not here. Let's go to the third level of difficulty for the 45, 45, 90. That is number number 6. When it diba from the short from the legs to the hypotenuse, you will multiply it by square root of 2. So do the reverse process if you will look for the legs and the hypotenuse is given. Meaning 10 here in number 6, the diagonal of a 45, 45, 90. It's 45, 45, 90 guys if the two sides are equal. Okay, so 10 divided by square root of 2. You rationalize. So that's basically 10 divided by 2. That's 5. And then times square root of 2. So we have 5 square root of 2 for number 6. So that is for the 45, 45, 90 questions. Carol, do you have questions?
No, miss.
Okay, that's fast. If the others have question, feel free to ask me. I don't bite. I'm not easy to get angry, no, so you're free to raise your questions. Sige, I'll proceed now to converting na everyone. Converting degrees to radians, we have two angle measures being presented. We have degrees and radians. Actually, there are a lot of ways to name an angle, but let's go first with the basics now. So how do we convert? Always remember this pair, 180 degrees and pi. They always go side by side and not side by side, bottom and above, no, in our converting process. Okay. Let's start with the degrees lang, degrees, 76 degrees. If you want to convert it to pi, do not look for the unit circle graph where the corresponding radian measures are given. Kay, I won't allow you to use that one. You really need to remember and identify and convert angle measures. So 76 degrees, diba you need to cancel the degree sign in order to convert it to pi with the pi symbol. So to remember, the number with a degree sign, which is 180 degrees, should be below the bar sign. So we need to multiply it by pi over 180. So with that, you just multiply numerators to numerator to numerator, denominator to denominator. So that's 76 times pi, 76 pi, and then 180. No more degrees. Okay, what's the purpose of converting if we still have the degrees, no? So we can cancel the degree sign, and that will give us 76 pi over 180. And you can simplify that one into 19 pi over 45. Do not forget the pi if you're converting to radians. Na. Sige. And the other process, what if from radians, instead of radians, miss, why do you keep on saying radians? What is that? That is an angle measure with a pi. Okay? So let's convert it to degrees, kaning pi over 4. So your goal is to cancel the pi to have the degrees only. So your pi now is below the bar sign, so you can cancel it. So after canceling, you are left with kani 1. We have 1 here times 180. That's 180. 4 times 1 here. You cancel pi, that doesn't mean that it's 0 there. It's 1. So 4 times 1, that's 4. And 180 divided by 4, that can be simplified to 45 degrees. So just remember na lang this two. Questions regarding converting degrees to radians. Inigo, do you have questions?
None, Ramis.
Okay, I'll proceed now to coterminal. You can review this PowerPoint in Alam 34 Goals channel ha. Let me know if the formatting is messy because I'll upload a PDF version. Activity 3. This is not the last. Activity, second to the last activity that I gave to the class. So let's start with coterminal angles. Coterminal angles is basically adding 360 or subtracting 360, adding 2 pi or subtracting 2 pi. Let's know one by one when to use add, minus, and then pi, and the degrees. If you're given with the degrees, your answer should be in degrees. And in looking for the coterminal angle, you just keep on adding 360 degrees. As simple as that. So for 450 degrees, you add 360. 450 plus 360. That's 810 degrees. Do not forget the degree symbol. And then 810 plus 360, that's 1,170. 1,170 plus 360, that's 1,530 degrees, and so on and so forth. So that's how you determine the coterminal angles. What just differ from all of these measures is the number of revolutions. Diba, 360 degrees is one full revolution. Like from the positive x-axis, and here, you need to know which one is the positive x, the negative x, positive y-axis, negative y-axis. One revolution is from the positive x-axis. It revolves around our coordinate plane and going back. That's 360 degrees. Okay? So, since we are asked with one positive, so we add 360. And then if we will be asked for the negative coterminal, we subtract 360. But guys, 450 degrees minus 360. That's 90 degrees. And obviously, it's not negative, so it still belongs to positive coterminal. So in order to get a negative answer, you add 360 to 9, you subtract 360 from 90, and that will give you negative 270 degrees. And subtract again, that's negative 630 degrees, subtract again, negative 990 degrees, and so on and so forth. I can ask you 1,000 number of coterminal angles, okay? It's just as easy as that. So we have a lot of possible answers for our negative and positive coterminal angles. And then for negative degrees, if you will be asked of the positive coterminal, negative 2 to 5 plus 360. So use your calculators, or you can do it manually. That's 135 degrees. And then add another 360, that's 495 degrees. Add another 360 degrees, that's 855 degrees, and so on and so forth. And it's already a negative. How can you still look for the negative coterminal? You subtract 360 degrees. So negative 2 to 5 degrees minus 360 degrees, that gives you negative 585 degrees. And then subtract another 360 degrees, that will give you negative 945 degrees, and so on and so forth. Okay, now the question would be, Miss, how do we graph that one, Miss, in the coordinate plane? But you need to know that basic skill in plotting. Take note, everyone, if the angle measure, be it in radians or degrees, is negative, the rotation is clockwise. Observe your clock and then notice its direction of the rotation. Kana siya, the same direction, that's negative. Okay, counterclockwise, ending with the violet here, with the arrow that signifies the direction of the rotation, that's positive if it's counterclockwise. And then let's go graphing. Or Start with the basic angle, 138 degrees. Kani, remember that the interval for each quadrant is 90. So from positive x going to this positive y, that's 90 degrees. And the 90 degrees going to this line, the negative x-axis, that's 180 degrees. And then going to this line here below, okay, this line here, that's negative 270 degrees, right? I know, not negative, positive 270 degrees. Okay, 180 plus 90, that's 270 degrees. And then going to the positive x-axis, that's 360 degrees. Okay, our rotation was counterclockwise, that's why it's positive. If it's negative, coming from the positive x-axis, we'll start here, going below, that's negative 90. Okay, again, the interval is 90 degrees. And then going to this negative x-axis, that's negative 180 degrees. And then going here, that's negative 270 degrees. So observe that the quadrant changes if we have a negative angle measure. Okay, so let's plot 138 degrees. Diba 138 degrees, if we'll have it here, that's 90 degrees only. If we continue here, that's 180, and we only have 38 degrees. So that's 90, and then it's 138. How much more? That's 48 degrees. So we exceeded like 48 degrees, or just half of kanisha. We can have it kanisha mas inclined, more inclined to this one. Okay, this is not 48 degrees. But anyway, the position is here in quadrant 2. And then kaning 450 degrees. Look at the red graph. One revolution, that's 360, and then if you plus 90, that's 450 degrees. So our angle is a quadrantal angle. It lies on the axis manisha. Negative, kaning negative 2 to 5 degrees. From here to this line below, that's negative 90. Going here, that's negative 180 degrees. So we still need more. 180, and then it's 2 to 5. That's 45 degrees more. So we like add 45 degrees from this line here. That's why we have the terminal side on the second quadrant. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Okay? For pi angle measures, if in degrees we will add 360, in the pi we add 2 pi. Okay, 360 is equivalent to 2 pi. Ano man, let's be familiar with this ha. One revolution, the 360 is equal to 2 pi. So half of the revolution, that's a pi. Okay, so if we continue to divide this one here, the 90 degrees, it's pi over 2 actually. Okay, so in determining for the coterminal angles, 2 pi over 3 plus 2 pi, so you can use a calculator for this one. I will allow calculators lang, no, so that you can add faster. So 2 pi over 3, what I did is just 2 pi over 3. 2/3 plus 2, that's 8 pi over 3. Don't forget the pi since it's in radians. And then plus 2 again, it's 14 pi over 3 plus 2 again, that's 20 pi over 3, and so on and so forth. If you will be asked of the negative coterminal, of course your angle should be negative. Instead of adding 2 pi, you subtract 2. Subtract 2. 2/3 minus 2. O verify that daw in your calculator. 2/3 minus 2, that's negative 4/3. Then add pi. Minus 2 again, that's negative 10 pi over 3. And continue to do that until you get the number of negative coterminal angles that is asked. It's possible negative coterminal angles there because you have infinite possibility or infinite number of coterminal angles, and I am only asking for one. Okay? The same for negative. Kani, the question is, how do we graph radians? Kani siya. My technique that I am using, since honestly I did not memorize the positions of the radian in the coordinate plane, I convert it to degrees. That's why it's important to know how to convert. Here, negative pi over 4, converting into degrees, that's negative 45. And negative, it's rotating clockwise. So starting here in our positive x-axis, it goes down. And it's 45 only, so it doesn't reach this line here. It's just half, okay, it's 90 interval. So we have here negative pi over 4. Then if you will be asked, no, of plotting the coterminal angle, negative pi over 4, if you subtract the first two, that's just one revolution and then same position of the angle. If you subtract another 2, you revolve twice, that's 1, and then 2, and then there, connection. The rotation will help us in determining the position. And then just use the radian measure in naming the angle. Okay, so that's for coterminal angle. Questions? Rufino, do you have questions? Kyle, do you have a question, Kyle?
No, miss.
Okay, we have 2 Kyles. Sorry. Thank you, Kyle Echevarri, for that one. Next is, I'll be discussing reference angle, but since we exceeded time, it's up to you if you will stay. I'll continue to discuss reference angle. For those who wanted to stay, very good. Okay, lastly is the reference angle. So in reference angles, everyone, there are things that you need to remember. First, it should be positive angle. Second, it's the measure between the terminal side and the x-axis. So refer to the x-axis always. The angle between the terminal side and the x-axis. The x-axis is the horizontal line. So we'll start first with basic. That's number 2, 72 degrees. It's positive. It's lesser than 90. So Tanisha, in plotting, we have this one, 72 degrees. So the reference angle is just 72 degrees. As easy as that. It should be lesser than 90. Okay. And if it's a negative number, so in reference angles, everyone, you need to plot first. So if in the coterminal angle, we can give the answer right away. In the reference angle, we need to really plot it first so that we'll know the remaining angle that will complete our revolution, or that will get us to the x-axis. So negative 300 degrees is, it's negative, so it's rotating clockwise. And this first line here, that's 90 degrees, this one is negative 180 degrees. This one here, it's negative 270 degrees. So we need to move further. If we will reach it, if we will reach here, that's negative 360 already, and it's only 300. So from 270, we need 30 degrees more. That's why we have here. Okay. The reference angle is this, the blue one. So how much more angle do you need to complete the circle? It's a circle, man, one full revolution. So that's 60. You'll know, kay diba, as I said a while ago, from 270 we need at least we need 30 degrees more for our terminal side to lie on the coordinate plane. That's why we have the terminal side here. Here. And then, diba each quadrant is 90 degrees? So if you already have 30 degrees here, so 90 minus 30, that's 60. Sorry, our reference angle is 60 degrees. That's why we have this one here. Or you can refer to this solution that I put here. One full revolution is 360. So in order for this red to reach this positive x-axis, we need 60 degrees more. So our reference angle is 60. Okay, and let's have 970 degrees. Let's plot 970 degrees first. One full revolution, look at the red. One full revolution is 360. Two full revolutions is 720. Hala, I ended here, so it's wrong pala no, the red one. Sige, take note of this one. Two full revolutions is 720. So that's, wait lang. 1, and then 2, and then that's 720 plus 90. 720 plus 90. 810. So here it's 810 here, and then plus 90 again. That's 900. So 900 here. If we add 90 more, that's 990 to reach this part here, and it's only 970, so it doesn't reach it. So from kani, which one? Pila ganini? 900 degrees. So in order to get the 70 degree, 970, so you need 70 more, 70 degrees more. So with that thought in plotting the graph, you'll know from this x-axis to this terminal side that rotates, you have 70 degrees for the reference angle. Okay, guys. This is the measure between x and the terminal. It's not the smaller part, which is kanisha and the vertical line. It's not that one. Okay? Sige. Question so far with the degree angles, finding for the reference angle of angles in degrees. Earth, do you have a question?
Hello?
Yes. Do you have a question, Earth?
Miss, the thing I was very confused about, Miss. I missed that manggod, Miss, because I joined late, Miss, is kanang kuan, Miss. How to get distance with kanang kuan, Miss. Only one of the kanang kuan, Miss. Only one of
Right.
the sides and an angle.
Okay.
I missed that part, Miss.
We'll go back to that after all the topics. Is that okay, Earth?
Of course, Miss.
Okay, thank you. So far, with yes, marry me.
Miss, question ra, Miss. Since it's if it's a koan, Miss, like since the negative is going clockwise, right, Miss? So even if the like before ganina, Miss, that was like a negative number, right, Miss? This one.
Yes.
Why is it positive 60, Miss? Like, is it counting lang padong? Why can't it be negative 6? I mean negative. Oh wait, never mind, Miss. I got it na.
Okay, what is the answer to your question?
No, because it would make it negative 360, and like we're looking for the. I got it na, Miss.
Okay, the correct answer to your question is reference angle should always be positive.
Oh, okay, thank you, Miss.
Although you need negative 60 to complete a negative 360 rotations, but you disregard the sign, everyone. Okay, reference angles should always be positive.
Thank you, Miss.
Good question. Thank you also. Okay, no other questions regarding this because I proceed to the radians. Okay, I'll proceed now to radians. Diba, as I said, for if you will be asked about for the reference angle, you need to plot first. And it's in radians, so it's hard to determine the position of the angle on the coordinate plane. That's why, as suggested, as I taught you, sorry for the notification, as I taught you, convert it first to degree sign so that it would be easy to plot your angle. So we have negative pi over 4. Converting it to degrees, we will multiply it with 180 over pi to cancel the pi, and we get negative 2 to 5 degrees. So with negative 225 degrees in mind, it would be easy for us to determine its position. Okay, it's negative, so we are rotating clockwise. So from positive x to this line, that's 90. Going this, that's negative 90. Going this is negative 180. And going here, that's negative 270. Again, remember the 90 degrees interval. And it's only negative 2 to 5. So from negative 180 here, we just need 45 degrees more for this one. So we have this part. Okay, so that's negative 5 pi over 4. Although it's negative 2 to 5, in labeling, use radians. Okay, the measure, the given measure is in radians. Okay, and now let's answer the question, what's the reference angle? Diba, as you plot, you will say it. If you will answer it on your own, you can say it to yourself that you needed 45 degrees more to go to this angle, to plot this angle. So that 45 degrees, you convert that into radians. I did not have it here, but convert 45 degrees to radians, it will give you pi over 4. Okay, another solution, ganing 5 pi over 4 that we have in red, we subtracted pi from it. Why pi? This straight line here, from the positive x to here, that's 180 degrees, that's equal to pi. Because I said, half revolution is just equal to pi. One full revolution, that's equal to 2 pi. Okay, so by dividing 5 pi over 4 by pi, we'll know the amount, or the measure, the amount of rotation that exceeded from the x-axis. So that's pi over 4. Okay, or 45 degrees. So that's the reference angle. Yes, Earth.
Miss, so if the kanang kuan, miss, if the question is on pi four, miss, the answer will always be in pi four, miss. You can't answer it on degrees.
Yes.
Okay, miss.
Okay. Any other questions about reference angles? Do you have a question? Ryan, si Hudo? Let's hear from John Steven. Do you have a question, John?
Yes.
Okay, thank you. Everyone, that ends my discussion about LM34. That's all about our summative test. If you still have questions, feel free to raise that one right now.